Okay, final accumulation problem here before you take a quiz on one of similar context. This time we're talking about a storm that's washing away sand from a beach, and that causes the edge of the water to get closer to a road. So as I'm reading this problem, let's look at the important stuff. I see, first of all, the word rate, at which the distance between the road and the edge of the water is modeled by this function. I'm going to underline my units as well, just so that I keep those in the back of my mind. The edge of the water was 35 meters from the road when the storm began, so that's an initial condition. I'm going to circle that so I know it's probably going to come into play sometime. The storm lasted 5 hours. That's probably important information as well. And then this time they give us the derivative of the function, so probably going to use that at some point in time. Let's look at the questions and see when we're actually going to use that. So part A, what was the distance between the road and the edge of the water at the end of the storm? Well, we know that we start 35 meters. The edge of the water was 35 meters from the road when the storm began. So that's where we start. And we're going to accumulate our rate at which the distance is changing. If we accumulate the rate at which the distance is changing, then we're going to accumulate the actual change in distance. So starting at the beginning of the storm, it said it lasted 5 hours. So from 0 to 5 of f of t dt, once more, don't waste time copying down that function. Spend the time typing it into your calculator because this is calculator active. You get 1 point for your integral. I'm assuming that includes the initial condition, because if you don't have the initial condition, you're not going to get the right answer. So when you type that in, you get 26.494. It doesn't say to include units, but it never hurts to include units. So we're talking about meters here. All right, part B. Using correct units, this one does say units, so you can about guarantee, since it says using correct units, you're going to get a point for units here. It says interpret the value of f prime of 4. First of all, before I go any further, let me just think about this. F prime, that's talking about a rate, and f was already a rate, so we're talking about the rate of change of something that is already changing in terms of the distance between the road and the edge of the water. So notice we're plugging in 4 here, so that would be 4 hours after the storm began. The rate of change of the distance, what are we talking about? F of t is the distance between the road and the edge of the water. What is it doing? Is it increasing or decreasing? Well, the rate is positive, so it's increasing. And you need to say at a rate of 1.007, we need to include units here, meters per hour squared. Why is it hour squared? Because f of t was in meters per hour. They told us that in the problem, meters per hour. And then we're taking the rate of that, so you're adding another unit of time, so that's per hour, or per hours squared. So you get 1 point for the interpretation of f prime of 4, so that would be the fact that the rate of change of the distance is increasing at a rate. That's 1 point for that, and 1 point simply for your units. So even since it says, let's just use some common sense here, I would think that even if you can't come up with the correct interpretation, if you at least try to explain something here, since it said using correct units, you can almost guarantee they're going to give you a point for units. So even if you're not sure of your explanation, at least come up with some kind of explanation so that you can put units on that number, so that you could at least get 1 out of the 2 points there, instead of losing a point, an easy point there. Okay, let's look at part C. At what time during the 5 hours of the storm was the distance between the road and the edge of the water decreasing most rapidly? Okay, anytime you see these extreme words, most, maximum, minimum, least things like that, you should be thinking extreme values, which leads you to the derivative equal to 0 and your endpoints. Okay, your derivative equal to 0, so your critical points and your endpoints. So we would, first of all, just write down f prime of t equals 0. Most rapidly should make you think derivative, which should make you think critical point. So f prime of t equals 0. Use your calculator. Again, I wouldn't use the solve function. When trig functions are involved and when exponential functions are involved, I would not use the solve feature. I would graph it and find where it crosses the x-axis. So when you do that, you find out you've got two answers within your interval. You've got 0.66187 and 2.84038. So when I'm graphing this, I would change my window. I'm not going to go through the whole process of graphing it, but I would go to my window and I would change my x minimum to 0 and my x maximum to 5, because that's all I'm concerned with in this problem. The storm lasted 5 hours. I'm only concerned with up to time equals 5, so I don't even need to look at the graph for anything else. Okay, so go ahead and just change that window so that you're not distracted by things that aren't within your interval. That's just a little tip there. All right, so we've got those two critical numbers. So we need to we need to find f of 0. Okay, that gives us -2. We need to find f of 0.66187. When you type that into your calculator, you get -1.39760. You probably don't need that in many decimals, but it can't hurt. And f of 2.84038, we get -2.26963. And our last endpoint, f of 5, we get -0.48027. So the most negative, since it says decreasing most rapidly, we need the most negative number. That's right here. So we need to say it in words. It never hurts to say it in words. Your justification is all those numbers, but you need to present your answer in a complete sentence. The distance between the road and the edge of the water was decreasing most rapidly at time, you need to give the time, 2.840. And it was just asking when. It didn't ask for the rate. Let's check the problem. It just says decreasing most, when, at what time was it decreasing most rapidly. So you just need to give the time. And on the rubric, they say after the storm begins, but I mean, that's kind of a given. But it never hurts to be more specific. After the storm begins. So you get 1 point for considering f prime of t equals 0. So even if you can't get past that point, if you can at least come up with the idea, okay, most rapidly, extreme values, critical points, so that's derivative equal to 0. Just write it down. Even if you can't get any further, write that down, okay? On these free response questions, never erase anything unless you absolutely know that it's wrong. If you come up with any idea that you think could be applicable, even if you can't go any further with it, at least leave it there. You never know, you might get the point for it, okay? You get 1 point for your answer, and then you get 1 point for your justification here by checking your endpoints and your critical points. All right, last part. After the storm, a machine pumped sand back onto the beach, so the distance between the road and the edge of the water was growing at a rate of G of P meters per day, where P is the number of days since pumping began. Write an equation involving an integral expression whose solution would give the number of days that sand must be pumped to restore the original distance between the road and the edge of the water. All right, so let's think about this for a second. We need to replace everything that disappeared. So our integral from 0 to 5 of f of t dt, okay, that represents the distance that grew. Now, we're going to stick a negative in front of it because think about it. We're trying to replace that. We want to, that's how the distance increased. Well, we want to take it back away. So we're going to put a negative in front of that. And then that's got to be equal to, we're replacing it with this g of p dp. Make sure that you get those things on there right, okay? We're starting at time 0, and then we don't know how long it's going to take. So we have an x there for the upper limit because that's what the question is asking. Write an expression that would show how to find how long. Well, we don't know how long, so we've got to put an x there as our upper limit. So you get 1 point for the integral of g, and 1 point, I would assume, for just setting those two quantities equal to each other. So again, even if you're not quite sure about what to set it equal to, you could probably come up with the integral there for the pumping it back on. You know that you've got to accumulate what you're pumping. So at least write down that integral expression, if nothing else, even if you don't know exactly what you need to set it equal to. All right, so you get 2 points for that last part.